Here's a little project I've been working on with the Raspberry Pi processor, the RP2040, and a display and some push switches. I've been interested in the links between electronics and MIDI and music, and really getting into wanting to program the RP24 a little more and just see what's possible. So I started out with a little collection of components wired together with the DuPont connectors, and then decided to settle on a PCB design for which I dug out Fritzing. I had to have a little rummage around for various templates and things that would help me design that, but it was a relatively simple job of connecting the things together with tracks, putting in the wires in the correct place, and once I'd finished all that, I was able to output a Gerber from Fritzing and send that off to JLCPCB, and it's always a lovely time waiting for that PCB to arrive in the post. I did make one mistake on the design. I got to a couple wires crossed, or a couple tracks crossed, for the rotary encoder, and it wasn't initially obvious that that was a problem, but it turns out in Circuit Wizard, rotary encoders need GPIO inputs that are adjacent. So I'm using, I think, GPIO 26 and 27 now, but initially that wasn't the case. I've got a little SPI display, a colour LCD, and that's got a resolution of 320 by 240 pixels, 7 push switches, and an LED. And the idea is that I can upload through its USB connection a text file of chords, and then select that from the menus and decide what chords or how it plays those chords, whether it does an arpeggio in the background, what it's going to do with the bass line, and overlays a simple drum pattern. And these are just taken from tables which are also stored on the RP2040. Initially I used a little module which had a DIN MIDI out. They're quite big. The DIN sockets, the 5-pin DIN sockets themselves are rather large. So I decided, which I've never done before, to use the TRS 3.5mm connection for MIDI and buy a MIDI adapter. But it wasn't long before I found online a little MIDI module, which is a circuit board, has a couple connections for power and a serial MIDI, and the one I found had a loudspeaker connection as well as an audio jack. So my device actually has a general MIDI music playback device in there, but it will also output directly via TRS to a normal MIDI device, and rather pleasingly it will also output MIDI over its USB connection. So what do I have? Ultimately it takes that list of chords and allows me to select what kind of drum rhythm, what kind of arpeggio rhythm, what kind of bass line, and then while it's playing I can cue each of those in and out and make sure then that I've got some sort of simple backing, which is really great for practicing and experimenting and just doodling while this little Raspberry Pi 2040 chip powers the backing, keeps me in time, keeps me in pitch, but also adds another member to the band. So it's turned out to be a really useful device. There are some developments I'd like to do, like splitting a chord within a bar, so it may go for instance from a G to an A minor within the bar. At the moment it's stuck on the same chord throughout the whole bar. So a little bit of learning to do. One of the things that I hadn't used before, which was quite helpful in its design or the programming, was to use a bit of ChatGPT. I had the basic structure in my mind, and I'd experimented using microblocks as a programming language, but ChatGPT just helped me to structure my thoughts a little bit better and give me insight into the various modules I was importing, particularly those that controlled the LCD display. So it was useful using AI as a companion, but in no way did AI generate all of the parts of the program. It was conversational, using that support from ChatGPT. But the PCB, I was really pleased, has laid out well. The programming is working well, and there are probably some foibles with the programming that might trip it up and make it crash, but at the moment I think it's working rather well.